All right, so the first things, like the first four that you see up there are the sines and cosines. You do not need to write this down. This is actually on your purple sheet. It is on the left-hand side, right under your Pythagorean identities. Except if you notice on mine, I have them condensed way down. So instead of seeing 6 of them, you only see 3. So if you look at mine, when you're looking at sine and cosine, like sine says u plus v, and then it splits it, and then if you look in the middle, it says plus minus. Do you guys see that? So it means if it's sine plus, then you use plus in the middle. If you look at the cosines, see how they're flipped? It's opposite sign. Okay? So if it says add, you're really subtracting in the middle. I love it. It's how I like condense crap down, and it looks weird, but like you understand what it means immediately. I know. Well, and then if you take stats, we have p hat and y hat and like little birthday hats. Yes. All right. So finding exact values. You do not need to copy those. Remember, they're on your purple sheet. So I've got 2 problems. So the one on the left says cosine of 75. Is there a way to find 75 where I'm adding and subtracting something from the unit circle? Shane? Okay. Did you have another one? Same one. So this is going to be the same thing as saying cosine of 45 plus 30. We did another one in first period where it was 135 minus 60. And they were like, it works. And I'm like, yeah, I'm just lazy. Like, now I got to deal with quadrant 2. I could deal with everything in quadrant 1. When it comes to addition, it does not matter which order you put it in, because 2 plus 5 is still 5 plus 2. Like, that part does not matter. So, when I go to write this all out, I'm looking at my cosine formula, and it's got a plus in the middle, which means when I go to do it, it's going to be cosine of 45 times cosine of 30 minus sine of 45 times sine of 30. Now, do those cosines and sines have values? Yes. So, cosine of 45 is root 2 over 2. What is cosine of 30? Cosine 30, root 3 over 2. All right, sine of 45 is root 2 over 2 again. And cosine at 30 is 1/2. Root 6 over 4 minus root 2 over 4. Combine them, call it a day. Ta-da, we're done. Yeah, first period was like, okay, when does it get worse? I'm like, it kind of doesn't. Well, there's one at the end that I purposely put on there to throw you off, but once we go over it, you're going to be like, oh, that's it? All right, cool. We can do it. All right, what about pi over 12? Any ideas? You're wanting to use a pi over 6? We could do pi over 6 divided by 2, but nobody wants to do that. Hi. I have no idea if Cammy's down. I have not tried it. I'm recording. I think, nope, Cammy's down. Okay. Yep. Yeah, that was going to be my idea, was pi over 3 minus pi over 4. All right, because when you go to get common denominators, it's 4 pi over 12 minus 3 pi over 12, which just gives me pi over 12. Do you guys want to try this one on your own, like with a neighbor real quick? Give it a whirl? Okay. Have you guys ever heard of down detector? It literally just tells you if there's outages on stuff. the entire purpose of the website is it working, yes or no? I was wondering if they had Cami on here, but I don't see it. But Delta's down. But it makes it really easy when kids are like, oh, Google Classroom's down, and I pull up Down Detector, I'm like, no, it's not. I'm like, oh, crap. I've been caught. Yes, no? Cool. All right. Not as bad as we were expecting it to be. Looks terrifying, and then you go to do it, and you're like, oh, that's it? All right, fine. And especially knowing you have your purple sheet all the time, like, okay. All right, so this one is, we're going to prove an identity. No, you may not use the fact that this is, what? Cofunction? That's like using the word in the definition. We're not doing that. So take a second. Which one do we want to write the proof out for? The sign? Did you want to do the sign or the cosine? Oh, yeah. We're going to prove it. So I say we try that one. Well, we just did a whole bunch with cosine, so why not? We all have personal preferences. All right. So when we go to do this as a proof, all right, we're going to use our sum and difference formulas for sine. So for sine, it always starts off with sine of pi over 2, cosine of theta, minus, because I have to keep those signs the same, and then it's cosine of pi over 2, sine of theta. That's it. Now, what are you thinking is our next step? EV. I could do that. What else? Doesn't sine of pi over 2 have a value? What is the sine of pi over 2? Well, it's 90, but what is the sine? What's the y value? 1. So this is just 1 times cosine of theta minus the cosine there is 0 times sine of theta. So I'm going to use my unit circle. So what's 0 times anything? Cool. Everything else disappears. Cosine of theta. All I did was simplify. Easy enough? Yeah? All right. Ready to scroll? All right. Do you guys want to try this with a neighbor? All right. That's what kind of makes it nice is, okay, like they're all the same, which is great. Ooh, all right. You'll notice a lot of these, they all end up with similar or the exact same answers when you plug them in and simplify it. It's just because they're all in the unit circle, so there's only so many different combinations we can make. Ready to scroll? We want to talk about it? Yes, no? Okay. All right. Here's another one I want you to try. What are we noticing about this one? Yeah, it's already expanded, so could we condense it down? So if it goes sine and then cosine, it's going to be a sine function. And then if it's minus here, and then what is the sine of 60 degrees? Not bad? I don't know.
It has a tongue coming out of the little.
All right, so for this one, start just by writing out this top part. And if you can't do the little alpha or the beta, just make it an A or a B. Also, in case you didn't need 2023 to be any weirder than it already is, it snowed in Phoenix, Arizona yesterday. But it was 70 degrees here. I don't know what's happening anymore. The rules are made up. Yeah, we've already had UFOs. Just copy down this first part. And then we're going to draw it in a minute. And then we'll fill these in. It was just too much to type in the math type part. And then whatever chips you want. Whatever chips you want. Okay. How are we doing on the writing part of it? We okay? Alright. So I'm going to do this in parts, and we're going to draw pictures. So I know sine of whatever this angle is 4/5. Now what does this piece tell me? Which restriction? Okay. But what quadrant do I draw it in? 2. So it goes between 90 and 180. So I'm going to draw it like this. All right, so I've got my alpha, right triangle. Now they tell me it's sine, so it's 4/5. And it's in quadrant 2. So that means this is a -3. That's just Pythagorean theorem. With that, we're like as okay as we're gonna be. Now for sine of beta. All right, what quadrant is this part? 3rd. So it means it's down here. All right, here's my beta. Right, and then it's -2 and square root of 5, and that's in quadrant 3. So I'm going to have to use Pythagorean theorem to find my missing adjacent side. So I've got negative 2 squared plus x squared equals square root of 5 squared. All right, negative 2 squared is 4. So x has to be 1, except it's in quadrant 3. So is x positive or negative? Negative. All right. Do you see a little bit of the method to my madness? Because the questions are going to go through and be like, okay, well, what's the cosine for alpha? Cool. Adjacent over hypotenuse. I'm done. Leave it alone. All right, cosine for beta is negative 1 over square root of 5, which is also negative root 5 over 5. Okie dokie. Now, can I do this? What's with the tentacles? Oh, little rascal slave. Yes. All right. Do you guys want to do them with me? Do you want to try them on your own? I was going to say, you've got all the pieces. You just got to put it all together. I wanted black. Put that in the wrong spot. But we're multiplying, so it works. I flip-flop sine of A and sine of B. Are we okay with that? All right, so I personally like rationalizing before I multiply. So it'll be negative 3 over 5 times negative root 5 over 5 minus 2 5 over 5. Put my negative times negative 4/5. 3 root 5 over 25 minus 8 root 5 over 25. Negative 5 root 5 over 25. All of the reducing. For which one? So that's actually sine of A. Because remember, that was up here. Oh, nope, it's 4/5. No, was it 4/5? Yeah, it's 4/5. Just kidding. Positive, positive, positive. That makes it a plus. That makes us 11. And we have some non-reducing. 11. Now we're done. Better? Yes? Okay. That's literally the worst thing that happens is you screw up the sign. Did you guys do part D yet or no? Want to do it together? Knock it out? Alright, so sine of A plus sine of B. So sine of A, we're going to write it as sine A cosine B plus cosine A sine B. Sine of A is 4/5. Cosine of B is negative root 5 over 5 plus negative 3/5 and negative 2 root 5 over 5. Finish them, I can pause it. What do we think? My math right? It's the little things that screw you up. That's literally all it is. Stupid sign. It's the positives, the negatives. It's always like basic arithmetic that messes you up, which is stupid. All right. We're almost done. How do we scroll up a little? Yeah? Okay. That part. Oh, to B. I got asked if I was a sub today. I'm like, dude, you literally have had me for like 2 years. Kid. Sophomore. Like, oh, we have a sub? I'm like, no, you don't.
Oh,
All right.
you like facing the other way or something?
Yeah. All right, so we've got an identity. It's a proof. Do you guys want to try it with me or without me? You want me to give you a minute and you can try it? And... Okay. I would mess with the left. Did we get here and then did we get stuck? So, if you got here and you got stuck, you can actually split this with common denominators. So, cosine A, cosine B, over sine A, sine B, plus sine A, sine B. Now, why would I want to do that? Yeah, the whole monstrosity on the right just equals 1. And then cosine of A over sine of A is cotangent of A. And then cosine of B sine of B is cotangent of B. And we are done. Yes? Cool? All right. I think we've got a little bit with tangents, and then we're done, and then you guys have a work day tomorrow. Woohoo. Here we go. Yep. So you do not need to write the tangents because they're on your sheet, but I still like showing them because, let's be honest, I have to look at them too. I don't remember all of these formulas. I have too much nonsense already in my brain. I also need like I'm sorry, I only have 12 decisions left for today. Please try again later. I need them. Yes. Limit for stupid questions of the day. Countdown. Be like, I'm sorry. Yes. Yeah. All right, so this one with tangent. Tangent at pi, does that have a value? What is it? Oh God. What is the tangent at pi? 0. All right, so if you've got a tangent, I would go straight into the formula. All right, so I've got tangent of theta plus tangent at pi Did we? Oh wow, because everything goes away. Yeah, because what is the tangent at pi? Yeah, it equals 0. That's just from the unit circle. So quite literally, I have tangent of theta plus 0 over 1 minus 0. That's it. Like, everything else just turns into zeros and it cancels. Oh, that's illegal. The old dead dude who found the proof. I know. Always got to deal with these old dead dudes. All right, one last one, and we'll be done. I was gonna say, it ain't that bad. Oh, hang on, I need my formula. Come here. Down. All right, last one. It's a proof again. Just write it down. We're not going to start the proof yet. All right, so what's going to be the problem with this one? It's undefined. How do I add undefined to something? You don't. So what we're going to do instead is, what do I know about tangent? What does it equal? Also over sine over cosine. Now we good? Yeah, a lot of stuff's going to start canceling off. But this is why I put this one, because first period's like, how do I add an undefined? And I'm like, I don't know. How do you add an undefined? So I was like, what if I just rewrote it? And they're like, I hate proof. I'm like, you're going to be just fine. I hate spelling. That's why I have Grammarly. And I still do it wrong. And I abbreviate everything. Cosine pi over 2 is 0. This one's 1. So that entire numerator simplifies down to just being cosine of theta. Zoom out just a little bit. The denominator. This one's still 0, this one's still 1. So this simplifies down to just being a negative sine of theta. And all of these steps here are some difference. So what am I left with when I put it all back together? Yep. Cosine of theta divided by negative sine of theta, which is negative cotangent of theta. Yay, we're done! All of the notes in one day.